Hello everyone and welcome to today's video. Myself Ankit. So in this video we are going to discuss about the major components of the Kubernetes and we are going to understand them from an architecture point of view, basically how they fits into the Kubernetes. This is important because these are some of the fundamental key components that we are going to discuss, like what is basically the daemon, what is the responsibility of your master server, how the API server basically responsible for the communication and how the interaction happens. Then we are going to discuss about the pods and how many pods, like how many containers we can run in a pod. So we are going to understand them in detail in this video. So the very first thing is, like, when we talk about the Kubernetes, there comes a Docker daemon and how you are going to create a pod, because in Kubernetes is independent of Docker, and that's why it has a pod inside which you can place containers. And since Docker is a container, so it is also supported by the Kubernetes. Now, the primary goal for us is to create a pod. This is what we want from the Kubernetes. Now, the way that you interact with the Kubernetes is through the kubectl. Now, kubectl is a command line tool through which you can interact with the Kubernetes. Same kubectl you will be requiring if you work on the Minikube as well. And this kubectl is basically going to make the API call on your behalf. So you are basically going to make a command line entry, but at the back end, it's going to interact with the Kubernetes in the form of an API. Now, this kubectl basically interacts with the master node. That's how basically the communication establishes through the Kubernetes cluster. All the calls basically goes to the API server that we are going to discuss after a few slides. And next, once you make the call to the master, it's going to interact with the worker node, basically the virtual machine where your container is running. Now, on this container, there is a Docker daemon which is running, basically your Docker server, which you can interact through the client. So what happens is, when you make a call through the kubectl, the master goes and interact with the Docker client, and in turn makes a call to the Docker server. Now, Docker server is going to interact with the Docker hub. It's going to download the image from the Docker hub onto the virtual machine, and then from this image there will be a container that will be created. Now, Docker image, think of Docker image like a blueprint to create your container. Without the Docker image, you cannot create a container. So this is a very basic detail of how you are going to use the different components inside the Kubernetes and how you are going to interact with them. Now, if we talk about the Kubernetes, basically what happens is that we are going to write a deployment file. Now, this deployment file basically consists of the configuration. It consists of the details of how many pods you want to run and how you want to create and you want to run your application. It gathers all that information. Now, once you have run, so it carries some information, like suppose I want to run one Nginx. So it will gather all the configuration about that Nginx, and that request will go to the Kubernetes API server. Now, for Kubernetes API server, since I already told you that in Kubernetes everything is an API, so now you are making a call to a Kubernetes which there is a API server. Now, this API server is responsible for handling all the things. Think of this like a single point of entry, and it is going to be responsible for logging everything. This is how you actually know all the requests that is being made to the Kubernetes cluster. If you want to compare it with a real world analogy, so you should think like, suppose if you created one house right now, what happens is that if you do not put a boundary, so anyone can enter from anywhere, right? This becomes a challenging for the security and knowing how many people are inside, then logging who came into the building and who left, right? So what you do is you create a boundary, you put a gate, and there is a person who is made at the entry, who is making people enter, and who is recording their entry time, where they have come from, ID like that. So you have a better tracking system in place, more security is placed. Same is with the Kubernetes API server. If you have to interact, all the calls will go through this Kubernetes API server. Now, within the Kubernetes API server, there is a controllers. Okay, one such controller is a replica set, which is going to maintain how many containers you are going to run. So within the master, you are going to dedicate the responsibility. So suppose you say that I want to run at least one container of Nginx. So what you want to run one container, and then it matches with the state of how many containers are running. Suppose if the no container is running, it will create it, but if the container is already running, then your desired state is equal to the running state. Now in that case, it will not take any action because your desired state is equal to the current state. Then it's not going to take any action. And basically what this Kubernetes API server is going to do is it's going to interact with the scheduler, and that scheduler is going to schedule the pod onto a worker node, where it will be interacting with the Docker server and going to place your Nginx pod over there from the Nginx image. Now it will download the Nginx image from the Docker hub, and that image will be going to the through that image. That's a blueprint, so it will be using that image to create a Nginx container, and that is how your container will be running. And now once the container has been deployed, entry of 1 will be updated inside the running, and that's how it basically creates your Kubernetes cluster. This is how the Kubernetes is able to run the pods inside your cluster. Now next, how many types of deployment can be there, like what type of configuration you are going to write. So we are basically going to write the config for all the objects. Now what are objects? There are basically different types of objects inside the Kubernetes, like your stateful set or your replica controller. Now replica controller and replica sets are there. Replica sets is a updated version which is able to run more number of queries. It supports the set based queries. And then there is a pod to run the containers, and then there is a service through which you are going to actually put the multiple containers in the backend. It is also going to route the traffic. At the same time, this is how you are going to expose your service, right? This is what we basically do for maintaining the multiple containers in the backend. Think of this like a load balancer service through which you are going to split the requests automatically in the round robin manner to the multiple containers. So this service is being exposed, and then you get the request. So these are basically the different objects within the Kubernetes. There are more objects, but these are the most commonly used. So you can write the config file for them, and once you have written the config file, you can deploy it on the Kubernetes cluster. Now while writing the config file, you will be using the API version. Now this API version, think of this API version like a hard coded. What this means is that this has been hard coded inside the Kubernetes. It helps it identifying the API that you are going to be using to interact, and what this basically this is telling the Kubernetes where it can find all the definition about that API. So there is a API version v1. Basically you can make for the component status, config map, endpoints, events, namespace, pod. And then there is a apps v1 inside which you can make a request for the controller revision stateful set. So if you have to deploy these kind of resources, then you will have to specify the appropriate API version while writing your config. Then only it's going to be, you are going to be able to run it. Now next comes your pod. So what is a pod? Think of this, that Kubernetes don't require the Docker to run. So basically what it has done is it has created a pod inside which you can run the container. So basically if I have to run the container, now I will be placing that inside the pod. Now when we talk about the pod has different set of characteristics than the container. Now if you look at container can be any of the technology. It can be Docker, it can be CRIO, then it can be Rocket containers. So it can be different types of containers, but then pod will always be there, which is going to run the containers. Now there is a further differences between the pod and container. So basically when you run the container, okay, you do not get a dedicated network, but in case of pod, we are having a dedicated network known as pod network. Now you can use the Calico network, which is like the most commonly used and recommended networking by the Kubernetes. And then the pod is having its own IP address, while the container don't have the IP address. So, but containers can assume the IP address which has been assigned to the pod. So Kubernetes is always going to schedule the pods, and since the pod are running the container, so they can be used interchangeably. So basically the pods are going to run your containers only. Now as a best practice, you should only run a single container inside a pod, but then if you want to run multiple containers inside a pod, that is also possible. So this is an ideal case where we are considering that there is a server on which we are going to run our containers. This is basically the working node workers node, and on this we are going to schedule the pod, which is the scheduler is going to schedule the pod which is going to be running. Now inside that pod we have placed a container which can be a Docker container, and we have created from the Nginx image. So this is the Nginx container. Now inside a pod you can have the multiple containers as well, although this is not a very right architecture because this creates a tight coupling, but the Kubernetes is based on the fact that you should have a loose coupling. Now if you look at the but there are some scenarios where you cannot avoid this. Like if we talk about, suppose in this example, there is a MySQL server, like the container which is running right now. This is running the database. So basically you need to have a logger in place which is going to log your slow queries, and if there is some error you need to put that. So you can have a separate container for that which is going to look for this MySQL logs, and then there is a backup manager which is going to back up this MySQL and maintain the high availability for that. So this is just an example for you, like where you can run the multiple containers. All these things are like MySQL logger and the backup manager are acting like a container which is running inside the same pod. So this is an example where you can actually go ahead and use the multiple containers inside the same pod. You might not have that much flexibility of running them individually because these all are tightly integrated. But then you should always try to put the single container because that's the best practice to be followed. So these are just some of the few basics of the understanding about the various components that you should be aware while going through the Kubernetes. I will be discussing more about the different components and the logic inside the Kubernetes in the subsequent videos. So that's all for this video. If you have not subscribed to our channel, I will suggest you to subscribe and get these videos delivered to your YouTube channel directly. Thank you, everyone.